All right, folks, let's take a look at homework 4.2. Here we go. So we got a pattern. It looks like it's drawn in figures, and we are going to try to understand that pattern, I assume. Arrange the information from the diagrams into an input-output table. Label the input column figure number N. Label the output column number of squares in figure S. Okay, so let's do that. Figure number N, and process goes in the middle, and number of squares, S. Okay, so we need to arrange the information from the diagram. So looks like I have figure 1, 2, 3, and I assume I'm going to look at 4 and 5 because I have space for that. So if I look at figure 1, there are 1, 2, 3, 4, 5, 6. Number of squares is 6. If I look at the second one, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I get 9. And I'm predicting, I'm just looking at the pattern, this went up by 3. I think I'm going to go up by 3 again. So I think it's going to be 12. I'm just going to make a prediction and see if I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It was right because I'm so awesome. And so you can also notice that it's adding on a new square to each end of the longer ends. So each end grows by 1 each time, and so that's 3 that it's increasing total. In the space to the right of the figures, draw figure 4. How many squares are needed to build figure 4? Add this information to your input-output table. Okay, so I know that I'm going to have the previous diagram. I'm just going to add on to the ends. So I have 1, 2, 3 on the end. So that's the previous diagram. So this is going to be figure 4. I know I need to add a square to the end of each side. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which makes sense with my pattern. I added 3 again. Okay, so I'll label that figure 4. Looks like they want me to do figure 5 as well. So let's do that. I know I'm going to take figure 4 because I have cool electronics. I'm going to copy it and then paste. And now I know all I need to do is just add a square onto the end. And so I had 15, and now I've added 1, 2, and 3, and so now I'll have 18. And I continued the pattern of adding 3, and that's 1 to each end every time. So create a graph of your input-output table. All right, let's go ahead and do that. So I know I'm going to need axes, so I'll go ahead and draw those in. Maybe not that arrow there. And I need a horizontal axis. I need to decide what my axes are. So figure number N is the kind of x variable, so I'm going to put that down here. Figure number N. I'm starting with my labeling. Number of squares is going to go on the y, and so I'm going to put that here. Number of squares, S. Put this in parentheses too. Okay, so we know what we're looking at. My figure number goes from 1 all the way up to 5, so I can stretch it out a little bit because I've got way more space than that. So I'm going to go 0. Maybe I'll make 3 squares worth 1, and then 3 more squares makes 2. Remember, you have to keep it nice and consistent, so each 3 square distance is worth the same amount. So in this case it's worth 1, and so that's a nice consistent looking scale. Now I need for my number of squares to go from 6 all the way up to 18. So again, I'll start at 0, and then I think maybe what I'll do is I'll count by 2s and mark every 5th one. So I'll do 2, 4, 6, 8, and then this will be 10, and then 12, 14, 16, 18, and this would be 20. And 22, 24, 26, 28, this would be 30. So I'll have plenty of room for everything I need to graph. So I need to graph 1, 6 first. That's the first row here, 1, 6. Whoops. So 1 comma 6, I'm going to go over 1 and then up 2, 4, 6. That's going to be right here. Okay, next one is 2 comma 9. So let's look at that closely. I start at 0, 0, go over 1, 2 on the x-axis, and then I'm going to go up 9. So 2, 4, 6, 8, and then halfway to 10 will get me to 9. So 2 dots down. 3 comma 12. So let's look at that one. Over 1, 2, 3, then up 2, 4, 6, 8, 10, 12 is right there. And I notice that it's making a nice line here. 4 comma 15. I go over to 4 and then up 2, 4, 6, 8, 10, 12, 14, 15 is halfway between 14 and 16, and then 5 comma 18. So I go over to 5, then 2, 4, 6, 8, 10, 12, 14, 16, 18. And that looks really nice. I've got a graph that is labeled, I've got a graph that's accurate, and I've used a lot of the space. So how many squares would be needed to build the 10th figure? Justify your answer. And so I think what I'm going to do is I'm going to find the process here, because if I know the process, then I can use it for the 10th figure. I'm going to use a strategy that we used in class today. I'm going to go count back to 0. And so if this was adding 3 each time, to go back to what would be across from 0, I'm going to have to take away 3. 6 minus 3 gives me 3. So because there's only one way to go from 0 to 3, and that's to add 3, I know plus 3 is part of my rule. Now you might recall too that Stephen in class today said that if you know what you are counting up by when the figure number is going up by plus 1, then you can determine what the multiplication will be, and it should be that number. So since we're adding 3 each time, our multiplication is probably going to be 3 times 1. I'm just going to check that. 3 times 1 plus 3 is indeed 6. 3 times 2 plus 3 is indeed 9. 3 times 3 plus 3 is 12. 3 times 4 plus 3 is 15. 3 times 5 plus 3 is 18. So that looks really good. And so I know that it seems like I multiply by 3 and then add 3. And so I'm going to use that process here. Because we're looking at the 10th figure, I'm going to do 3 times 10 plus 3. And that's just 30 plus 3 equals 33. And so I've justified my answer by using the same process. Write an explanation of how you can calculate the number of squares needed if you know the figure number. And so I think we might have just mentioned it. You can notice again that we've multiplied by 3 and added 3. And so take the figure number, multiply by 3, then add 3. And you should have an answer. Write an algebraic rule that gives the number of squares needed to build any figure number. Write your rule using the variables n and s. Use the process column in your table to help you if needed. And so if you haven't noticed this trend yet, when you look at a process column, it basically has your rule in it. And so I know that 3 and times are a part of every part of the process here. I know that plus 3 is a part of every part of the process here. And then I notice what's changing, and it's this number 1, 2, 3, 4, 5, and that number is n, the figure number. And so if I do that, I should get the number of squares, s. And so my rule comes straight out of my process column. What do you do in every single process row? That's going to be in your rule. And so I end up with 3n plus 3 equals s. Okay, so what figure number has 60 squares in it? Justify your answer. You might recall that we talked about working backwards today in class. And so this, we said, take the figure number, multiply by 3, then add 3. To work backwards, I'm going to start by doing the opposite of adding 3, which is taking away 3, and that's 57. And then I'm going to take 57 and I'm going to divide by 3 because that's the opposite of multiplying by 3. And I get 19. So figure 19. Okay, let's look at our staying sharp. Let T represent the number of tables in a banquet hall. Oh man, we love these tables in a banquet hall. And let C represent the number of chairs for each table. Is the expression C times T meaningful in this context? If it is meaningful, what does it mean? If it is not meaningful, explain why. So I'm going to use a strategy that Alicia shared with us when we were in class and working on this content. She said use some information, use some real numbers. And so I'm going to say that there are 4 chairs per table. And so I just said that C was 4. And I'm going to say that there are 5 tables. And so this is C equals 4 and T equals 5. And so I'm going to multiply those. I'm going to say C times T equals 4 times 5, and that is 20. And the question is 20 what? And if I can come up with an answer to that question, then this is a meaningful expression. If I can't, then it's not meaningful. And so I'm going to try to visualize this. I'm going to draw 5 tables, 1, 2, 3, 4, 5. And then I'm going to draw 4 chairs per table, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I've got 4 chairs per table. And the question is, does the number 20 that I got, does the number 20 that I got when I did 4 times 5 represent anything? And if I look closely here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 total chairs. And so the answer is 20 what? 20 total chairs. And so if you multiply C times T, it gives the total number of chairs. And so what I did there is I tested out some numbers that made sense. I drew a diagram, and then I asked the question, does it actually represent anything? Does 20 actually represent anything? And it did. So let's consider C plus T using the exact same example, because that's what the next question is about. I'm going to do 4 plus 5, and I get 9. And the question is, 9 what? I'm going to look back at my diagram and think if there's anything that 9 could represent. And so I know that there's 20 total chairs, there's 5 tables. I can't really see a group of 9 anywhere, or a total of 9. There's no part of this diagram that I could usefully use the number 9 to represent. And so I'm going to say that it's not meaningful because it doesn't help me understand my diagram. Okay. Teresa babysits for her neighbors. She charges $13 for the first hour and $10 for each additional hour. Write a rule for the total amount of money she charges T based on the number of hours she babysits H. Okay, so we suggested in class that anytime you need to write a rule, you should make a table. And so I'm going to put H for hours. And I'm going to make a process column because we love those. And then I'm going to make a T for total money. Okay, so I know that she has 1 hour and then 2 hours and then 3 hours we'll take a look at. I'm gonna go ahead and put a 0 in because I know how helpful having the 0 row can be. So I know for the first hour she charges 13, and then it's $10 more for each hour. So it's going to go up by 10, so it gets her from 13 to 23. Go up 10 more, and it should get her to 33. And so I'm 13, 23, then 33. That means to go back, I have to take away 10, and that should get me back down to 3. So I know that plus 3 has to be a part of my process. And the question now is, how do I get from 1 to 13, knowing that I have to add 3? We can use Stephen's hint again. Since we're adding 10, that means we're going to multiply by 10 as well. So 10 times 2 plus 3, 10 times 3 plus 3, and so forth should give us those answers. So my rule must be 10 times the number of hours plus 3 equals the total. All right. Angela also babysits for her neighbors. She charges $11 per hour. Which babysitter, Angela or Teresa, will charge less to babysit for 2 hours, 3 hours, 4 hours. So Angela is going to charge according to the following scheme. So hours and then total for 2 and then 3 and then 4 hours. Angela charges $11 per hour, so I think that's going to be 2 times 11. That gives me 22. 3 times 11 for 3 hours gives me 33, and 4 times 11 for 4 hours gives me 44. I can also figure that out because it charges $11 more per hour. So let's just compare. It looks like for 2 hours, Angela is cheaper. And I can give you evidence 22 is less than 23. 3 hours, I'm going to write a little smaller to make it fit. Angela charges 33 and Teresa charges 33. And so they both charge 33. And now for 4 hours, Angela charges 44. I'm going to have to add a row to my table here, 4 and then 43. So for 4 hours, it looks like Teresa is cheaper by $1. 43 is less than 44. Because if you take 4 hours for Teresa, it's going to be 33 plus 10 is $43. All right, and then we told you to skip the last one because it didn't print very well. Excuse me for the jostling there. And that's your homework for today. Thanks.